Okay, hi everybody, welcome back. This is chapter 7, section 2. We're going through mass wasting. And the first section has been on what causes things like landslides and other mass wasting events. Sections 2 through the end is going to be evaluating risk and how to mitigate landslide risk and things like that. So what kind of places have risk excuse me, for landslides? Well, pretty much any place that has any kind of slope. We talked about how slopes are the most common landforms on Earth, and anything that has a slope means that stuff can be moved downhill under the influence of gravity. And so just simply slopes happening affects that, but also other things that increase the tendency for them to happen, or the landslide activity, is, first of all, urbanization. All right, when we develop landslide-prone areas, it increases that, and we'll talk about that, why that is in a little bit later. Tree cutting, this you could think of that as kind of a form of urbanization because we use them for civilization processes, but also global climate patterns as well, which you could probably also say humans have some sort of hand in. So we're going to look at all those in detail a little bit later. If you look at a map of places that are at highest risk for landslide activity, look right here. This is the Appalachian Mountains. This is right in the middle of the mid-Atlantic area. If you look out towards where we have most of our mountains in the United States, the Rocky Mountains, there's actually remarkably few areas. So the question is, why would the low mountains like the Appalachians have such higher landslide incidence in the Rockies? You actually do have some here in Northern California. Why is this area and this area so much greater than where we have all the tall mountains? And the answer to that is that here we have a lot more humidity going on. We have a lot more tendency to rain. In Northern California, it's very humid and very foggy often, and so that rain can saturate slopes. Even though we have mountains right in here, it's not nearly as wet, and the water doesn't add as much weight as it does in places like the Appalachians in Northern California. So those are reasons why those are some of the highest incidences in Earth. I'm sorry, possibly on Earth, but also in the United States. All right, so that was section 2. Section 3 is the effects of landslides. What do they actually do? Well, obviously damage. Things moving downhill, big masses of rock and soil moving downhill can just inflict damage on anything it strikes. Buildings, structures, people, of course. I mean, people are buried with falling debris. When we talk about things like mudslides, we tend to think of mud as being this kind of smooth flowing thing, but all the debris that's in it is, if you saw the one video, the one guy said that it's kind of like 1,000 battering rams hitting you all at once. So people are very susceptible to being injured in landslides. Buildings, roads, all kinds of utilities are affected by slides because of the mass that moves downhill, creating inconveniences for us, blocking roads and blocking other transportation centers. Streams and rivers being blocked are all effects of landslides. And of course disease. When everything gets saturated with the same kind of dirt and mud, there's no drinkable water. There's really nothing that's clean. And so everything being dirty, disease becomes a major risk factor to victims of landslides. What are landslides linked to? Well, there's a lot of other hazards that they're linked to. Earthquakes can set off landslides, as can volcanoes. Storms can produce the water that is required for landslides to kind of kickstart downhill. And even fires can cause landslides. Fires on like forest fires and things like that. What can landslides cause? Well, flooding. We know that landslides can dam rivers up, and so if that water gets backed up, it can cause flooding, even tsunamis. We mentioned how in the Hawaiian Islands, there's believed to be giant landslides that cause tsunamis that happened hundreds of years ago. So all these things are links between tsunamis and other natural events. What are some good things about landslides? That is, natural service functions. You might think, well, what could there possibly be? So sometimes there are mineral deposits that are formed as a result of landslides. As that ground gets churned up, it can cause deposits to be formed, also deposits to be revealed and more accessible to us. It can also create new ecosystems as well. You've got bare soil exposed. You've got new opportunities for plants and animals to grow as the old stuff gets kind of turned up and churned up in the event of that landslide. All right, how do humans interact with landslides? Well, like I said before, urban areas. One of the things that does, we mentioned last chapter in floods, is that it increases runoff because it doesn't allow water to seep into the soil. Transportation networks. We talked about how trains and highways, people being kind of in the way right there. Those are increase the risk factor of people getting injured from landslides. Also, grading the land. All right, so that means leveling the land out. So if you have a hill, all right, so we have a slope right here, and you can't really build too well on a slope. I mean, you can to some degree, but if you take it and you grade it, so you cut in and make a place where you can actually build your house right here, you're creating a risk zone right there as you kind of cut in. So all these human factors increase the possibility of landslides. We can, however, do human things that decrease landslide incidents. We can build the stabilizing structures. If you had a house right here, over there on the far right, one thing you would want to absolutely do is build some sort of a retaining wall right there. And we can engineer things that do safely hold back slopes, but they have to be done right. Also, another big thing is improving drainage. We mentioned how the influence of water plays a big part in this. All right, the better we can get water wicked away from slopes, the less likely they are to liquefy and move down. All right, one thing in particular that humans do is timber harvesting, and this happens a lot up in our Pacific Northwest because they have a lot of very large trees up there, millions and billions of them, and so it seems like a good resource that humans can access. But harvesting them does present some problems. First of all, one practice that is very controversial is clear cutting. That just means taking a whole area and just cutting an entire forest down. What this does is it prevents it removes removing trees from that area. It prevents I guess I should say it actually allows the runoff of water and the water to move through the soil. Trees tend to prevent that. So cutting down trees prevents the prevention of running off of water and into the soil. Also, road building. As you build roads into areas to try to log trees, cutting into those hills can really interrupt the surface drainage and increase the possibility of some sort of a landslide. So like I mentioned before, anytime we remove vegetation, now we did mention in the first section that vegetation can add weight, but it does have a benefit as well, and that is the roots act like anchors. So we remove vegetation, large or small, you increase the incidence of landslide possibility. Like I mentioned, roads interrupt drainage and also cut into hillsides, increasing that possibility. The more we build at higher elevations where there's a greater relief, that is difference in high and low areas, you're putting people in harm's way. Grading, I mentioned earlier, how we kind of cut into slopes for home sites. Slopes that are over-steepened, that is steeper than the angle of repose mentioned in section 1, will allow. As slopes get over-steepened, that stuff isn't going to hold for very long, and it will soon be coming down. Anytime we mess with underground water, that presents a possibility as well. Irrigating our lawns and septic systems, all those things kind of interrupt the flow of water underground. And when we kind of build up with fill materials, we mentioned in the earthquakes chapter how the one part of San Francisco that was built on fill was very susceptible to moving in the event of the earthquake. Same is true with landslides. So all these things right here, all these human created events can lead to landslides. Look at this house right here. All right, this area, they cut into the hill, and there's no retaining wall. So this right here is a major point of failure where it could come down on this hill. There's also no retaining wall here, and you even see evidence of this would be kind of, you might call that slump, where this hill is kind of starting to come down. I certainly wouldn't want to be living here. Whenever you deal with cesspools or underwater drainage, that interrupts the flow of water underground. And even this lighter material right here, this would be fill. So they want to build their yard out, so they just put a bunch of stuff build it up on the side of the mountain. Man, this right here really creates a hazard for the people that live below. So all these processes are different things that people do to increase the potential for landslides. All right, ways to minimize the landslide hazard. So you've got these problems. How do we address them? How do we mitigate them? First of all, we got to tell people where these places are, where landslides are likely to occur. And there's scientists all over the world who it's their job to identify landslide-prone areas. Identify them and educate the public on who is at risk. We can actually, like I mentioned before, design engineering structures to prevent them, to either channel landslides to places where it's safe or even to prevent them from moving at all. Like I kind of mentioned before, warning people, that's educating the public. And also, after they've started moving, I kind of also mentioned this already, you can create channels where it will control where the slides start to move. So if you can't prevent it, you can at least direct it to some place that's safer. The best policy, however, is just to avoid developing where you've got areas that are at risk. Obviously, some people have already built on areas that they didn't know were at risk, but if you can identify areas ahead of time as high-risk sites, you can create policy to prevent people from building there. It's cheaper. Obviously, you don't have to undo anything, and it's the best, avoidance is the best policy in that regard. All right, warning signs for landslides. All right, wherever you have a crescent-shaped crack, all right, or any kind of terrace on a hillside, what that means is you got a slope like this that may have gotten over-steepened, or if it starts to kind of do this, that means that all this is kind of starting to move down. And so wherever you see these terraces right here, these almost like stair steps that are naturally forming, that means that the hill is starting to sag and crack a little bit. This can sometimes take the form of like a tongue shape. So if we're looking at the hill kind of like on the front, sort of like that, if you see sort of like a it looks like a Pac-Man ghost, I know, but sort of a tongue-shaped slump in the side of the hill, that is if you're facing the hill, that right there means that whole area is likely to come down. And we'll look at some of those examples in class. I can show you some examples. What else? Talus piles, all right? That means things have already started to calve off and roll down to the bottom. Talus piles are boulders at the base of a cliff. Any place where vegetation has been cleared previously, that meant stuff moved down before and is likely to have other landslides or avalanches again. Any place where bedrock has been exposed. Most bedrock is covered up with soil, but where it's been exposed means that soil has moved over it, so you've had a soil flow taking place, and it could happen again. I mentioned the tongue-shaped masses already, kind of like this in the lower right. Anything irregular about the base of a slope indicates that something has moved. Remember, most slopes, most landforms weather or erode kind of uniformly. Any irregularity means that there was something that happened there, some sort of irregular movement. And so what we do is we create hazard maps where there are places highlighted where landslides are most likely to occur. Okay, obviously right here, you can see mass wasting has taken place. Here's you might call that a talus pile right there, piles of boulders and deposits from the flow. You see all the vegetation that has been cleared out, even some bedrock right here, this grayish stuff that has been exposed right there. All this is telltale signs of some sort of a mass wasting event that took place. Like I mentioned before, here's a hazard map. And there's a key or a legend on here which indicates the places that are most likely to experience some sort of mass wasting event, so people can either take action or avoid building there at all. While we may not be able to prevent landslides entirely, there are some things that we can minimize, do to minimize their likelihood of happening. By the way, this should say is difficult. I mean, it's difficult to prevent landslides entirely, but like I said, we can minimize them. Most of it involves drainage. All right, if you've got a slope that is mostly soil or some sort of top layer, and water can drain through that pretty easily, at some point it will liquefy. So if you minimize how much water drains through it, that will minimize the likelihood of it moving. So many times you will see this in hillsides that drains where water actually kind of comes out, and so water comes into these drains here and it's prevented from going into the soil, which can move. The drains are pretty stationary, the soil is not, so as long as you send the water through the drains, it'll keep the soil from moving. Wherever you have an impermeable layer, that is some sort of a layer of, say, clay or something like that, or very, very dense rock, that'll prevent water from infiltrating and making the whole side of a hillside soggy. All right, like I said before, right here, a lot of times you'll see these drains if you're driving on the turnpike and you're going through a hill cut. All right, these drains are so that water can run off safely without infiltrating through the soil. You can also shore up a slope by adding concrete, all right, or soil cement that makes the side of the hill more stable and less likely to move. I mentioned before how grading, sometimes the practice of grading can be a bad thing, but if you grade in the right way, it can also be beneficial as well. Here we had a slope that was probably too steep. It was, maybe you might say, beyond its layer, its angle of repose right there. So what if you take a lot of the top material and you build it out horizontally so that the slope, I'm not sure you can see that green right there, becomes less steep. If it becomes less than the angle of repose, then that slope is going to be stable. So if you grade correctly, if you put some thought into it and some engineering, you can actually make a slope more stable. All right, right here is an area that it looks like, well, if you look here, you see all this exposed bedrock and down below some talus. It means that there could have been some sort of a mass movement down through here. Well, you don't want that because you've got a road, and so what you can do to kind of shore up this whole area is to put in slope supports, and these are basically kind of concrete walls. It looks sort of like a web right there, but it's just kind of like a crisscross mesh that shores up the slope. If this wall weren't here, you can see how this stuff would just be very likely to, oops, that's not a good color. Let's go with red. Would be very likely to just continue sliding down and probably erode the side of the road right there. But with that wall in place, that slope support, it makes the road more stable and likely to stay in place. Okay, so if you watch the video on the Nova video on killer landslides, the segment about the Swiss engineers was all about giving warning systems to people to provide time for people to evacuate. At one point, they said they were even able to predict a landslide down to the hour with the right amount of warning system. So monitoring is very important. All right, that gives you a greater degree of precision for identifying when an earthquake, when a landslide is going to take place. All kinds of various different technologies, tilt meters, and you've got lasers and radar and mirrors and stuff like that observe the side of a hillside and see how fast and in what direction it's moving. You can even detect lahars, which are actually volcanic related, but it is kind of like a mass movement, volcanic ash mixed with water. You can detect them acoustically by listening to see or to hear when these things are moving downhill. All right, and even wells. If wells get filled up, if you have, many of us probably have municipal water, but if you have a well in your backyard or somewhere on your property, if they get too high, that level gets too high, it can indicate that there's a lot of water in the water table underneath your property, and could mean there's too much water in your whole area or neighborhood that could cause a landslide to occur. Okay, some of these things are kind of common sense. I'm going to go through them pretty quickly. If your swimming pool or septic tank is sagging or leaking, first of all, you may want to just fix your swimming pool. But secondly, it could be an indication that if you're on or near a hillside, that hillside could be moving. Any small springs, that means where water is coming out of the ground where it wasn't previously. It could mean that there's some sort of crack underground caused by slow mass movement. Like I mentioned, curved cracks or tongue-shaped, any kind of surface features, and just out of common sense, any place that is identified as a landslide hazard, don't buy a home there. You also might want to apply that common sense to areas that are likely to have avalanches. You may not want to build your house at the bottom of a usually snow-covered mountain that is likely for avalanches to take place. If you are a skier or a snowboarder and are likely to be recreating in avalanche-prone areas, you want to get forecasts from whether it's the ski or snow resort that will tell you what places are safe. So even though you don't live there, if you carry out recreation in places that are likely to have avalanches, you can make yourself safe by getting educated ahead of time. So all these things are things that you can do to keep yourself safe in the event of a landslide, or to keep yourself safe from a landslide entirely. So let's use a bunch of this sounds a little too slang. Let's use a lot of this common sense and apply that to the La Conchita disasters that took place in 1995 and 2005. All right, so let's just kind of recap right here. Very scenic area, so people are likely to want to live there. It's a small community right along the Pacific coast. And it just seems, this word idyllic means just so peaceful and nothing bad could happen here. And so that can oftentimes be misleading. California is known for seismic events, and so wherever you have any kind of earthquake or even volcano, which is related to earthquakes, you have the likelihood of that causing stuff to move downhill, material to move downhill in the event of a landslide. So before 1995, people actually saw cracks that existed in the upper part of that hill right there. That should have been a warning sign. But it was really the heavy rainfall that added to that caused it to move downhill very rapidly. All right, this is just a little bit of a close-up of La Conchita. I believe I've shown you pictures from Google Earth as well as to where this is, but it's right on the Pacific coast. Not a whole lot of place to go in the event of some sort of a landslide, because you've got your hills right here, a little bit of a plain, and then the Pacific Ocean right there. So any movement down this slope, people are going to be pretty much trapped and not really have much of a place to go. Here's a couple afterwards pictures. Well, this one is right here, and you see it's right against the Pacific Ocean, and cars and all kinds of stuff swept out to sea because of this this landslide. You see these tongue-shaped kind of cracks right here. There's also some over on this side and this side as well. All are evidence of previous mass wasting that took place above La Conchita. So that should, again, tip us off that this is a really high-risk area for landslides. So again, this is a recap of kind of what I mentioned real quickly at the beginning of the chapter, that after 1995, in which no people died, they did a landslide risk study. And they found that it shouldn't have been too hard to identify that landslides were very common in that area. There was other tongue-shaped cracks that indicated that landslides had taken place up or down the coast from La Conchita. In fact, much of what they built on was previous landslide deposits, so not very consolidated, probably pretty loose stuff. So a lot of the plain near the ocean, where the cliffs slope down, was probably previous landslide deposits to begin with. They even made some recommendations to make the area less landslide prone and to make them safer. Benches being kind of like walls that kind of cut into the hillside right there and reduce the slope. I showed you that a little bit earlier. That was one possibility, and also a dewatering system, or a system that would drain water away. All these were proposed, but they were just too expensive to do, at least in the eyes of the citizens of La Conchita, and so not as much was done. They did a little bit of a draining system and a smallish wall, but that clearly wasn't enough. So here's a few pictures of the retaining wall that was built prior to 1995. And this is right here, this is the toe of the flow that prevented the wall from coming any further down onto the road right here, which is evidently all people really cared about, just keep it off the road. And this wall really wasn't big enough to prevent a larger flow. Now, if it wasn't for lack of education, people were repeatedly warned between 1995 and 2005, and some people actually did leave after 1995. But being such a nice place, Southern California, warm, sunny, by the ocean, many people bought property later on. Maybe people that didn't know about the 1995 event. And some people just figured, well, it was safe now that we put up a little bit of a wall right here. But in 2005, one thing that set this off was more than 2 weeks of just crazy rainfall, all right? All that water being saturated into the hillside just had nowhere else to go, and was going to bring the hillside down with it. And so this was a very, very rapid movement downslope, probably kind of like a debris flow or a quick earth flow, and that retaining wall didn't even stand a chance. It damaged a lot of houses, killed even 10 people, and part of it was because they really had no time to escape. It just moved so fast. So that was 2005. And right here is, I'm not sure if this is La Conchita or not. I don't think well, it could be. But obviously, if you're in your house and this material comes down and bashes down your house, you're not going to really have any place to go. It looks like this has actually been partially excavated as well, so it could have even been built up higher at one point. But really, it's warning and education and taking action that's going to save you in the event of a landslide. So after 2005, one thing that they did was they actually identified that an avocado ranch, which was right above La Conchita up on the bluff, was partially responsible for bad drainage practices, and that that ranch owner was negligent and could possibly have contributed to the failure in 2005. Now that doesn't solve the problem that people have died already. So really, the best practice is prevention, not taking action afterwards. And so, as of 2010, they identified that $50 million could build structures and build systems that could protect most homes in La Conchita. Even so, they haven't done much about it. Again, people get a false sense of security, especially being warm and dry most of the time in Southern California. And it's really the fact that we need to educate people to keep them safe, to prevent these things from happening, or at least prevent people from being affected by them, not doing things afterwards. So that's it for the last part of Chapter 7. I hope that made sense to you. If you have any questions, come see me. But for the time being, thanks for watching, and I'll see you on the next one.